This is a brief guide to determining bonding from the periodic table. There are three types of elements in the periodic table which are important. There's the metals, which in this table are the grey, the non-metals, which in this table are green, and the semi-metals, which are pink. And how they bond with each other tells us a lot about the type of bonding that they undergo. Metallic bonding occurs when two metallic elements bond together. These kinds of bonds are characterized by the fact that we have solids that typically have crystalline structures and conduct electricity. Ionic bonding occurs when a metal and a non-metal exchange electrons to become ionic. Typically, ionic compounds are solids at room temperature and are characterized by their ability to conduct electricity when they are dissolved in water. When electrons are shared between two non-metal atoms, we have covalent bonding. When the sharing is even, we have non-polar covalent bonding. When the sharing is uneven, i.e. the electrons spend more time at one atom than the other, then that is polar covalent bonding. This is a summary table of the types of bonding that we've already covered. Try to turn it into a flowchart as a really cool study tool. We can also determine the type of bonding using electronegativities, and this is what I'm about to show you now. Linus Pauling defined electronegativity as the ability of an atom to pull electrons towards itself, and that's how he got his own scale. Fluorine is the most electronegative element, and its electronegativity is usually defined as about 4, depending on the calculation. The least electronegative element is francium, and its electronegativity is around about 0.8. By comparing the electronegativities of the atoms on either side of a bond, we can determine how covalent or ionic it is. The greater the difference between electronegativities, the more likely it is to be ionic. As you can see here, the difference between the hydrogen and the carbon electronegativities is only around about 0.35, which makes it non-polar covalent bonding. And if we have a look at sodium and fluorine, we notice that the electronegativity difference is about 3.1, and that makes it an ionic bond. The final example between hydrogen and oxygen shows an electronegativity difference of about 1.24 Paulings, which is a polar covalent bond. I have a few problems here for you to try. So use the information that is attached to this video and see how you go. The answers are coming up shortly.